Hey there, guys. We're going to be looking at kind of word problems and modeling today, um, using function notation, things like that. Always kind of one of the trickier things that I've taught. Just that you're having to read a lot and make that translation from the English word problem to the mathematics, and then a lot of times afterwards we ask you to interpret your answers, just say what they mean, and so then you're having to translate back from the math to the English, and so just making those translations tends to be tricky. So I'm trying to give you tips on how to do that, things you should be looking for, ways you should write things like that. So just starting off talking about function notation. So a lot of times we replace y with f of x instead, right? So these things are interchangeable. We use function notation because it allows us to evaluate a function, right? So that means find the y value, add a specific x value, and we're going to talk more about that later in the next unit. But right now we're just going to look at some equations and turn them in, how we would write them in function notation, and then use our function notation to then evaluate those equations. So if I want to take y equals 3x minus 7 and rewrite that in function notation, so since f of x is going to replace y, so it's ready to go. So all I have to do here is just say, that would now be f of x equals 3x minus 7. So not much to do there because y was already isolated. And then when I want to use that function notation, so it says f of negative 2, so basically, since x here is being replaced with a negative 2, then I replace all the x's in the problem with negative 2's. So I'd have 3 times something minus 7, my something now being negative 2. And of course 3 times negative 2 is negative 6. Negative 6 minus 7, which is negative 13. So generally you would write f of negative 2 equals negative 13. Same thing on the next one. So replacing the x in function f with 3. So there'd be 3 times 3 minus 7, which of course is 9 minus 7, which is 2. So you'd say that f of 3 equals 2. This next one, so notice as I try to, if I wanted to get this into function notation, and that idea that f of x replaces y, so noticing that y is not isolated here, that's the first thing I need to do is isolate y. So just subtract 3x from both sides. So I have 2y equals negative 3x minus 1. And then I want to divide everything by 2. And so that would mean that y is negative 3 halves x minus 1 half. And so in function notation, I'd say f of x equals negative 3 halves x minus 1 half. It's a little bit more work there. So using the function notation, so plugging in negative 2 into that. So negative 3 halves times negative 2, and minus 1 half. Well, negative 2 divided by 2 is negative 1 times 3. Negative 3 is positive 3. So I'd have 3 minus 1 half, which of course is 2 and a half. So f of negative 2 equals 2 and a half. And then f of 3, so it'd be negative 3 times 3 minus 1 half. 3 times 3 halves is 9 halves. So it'd be negative 9 halves. Make that better. negative 9 halves minus 1 half would be negative 10 halves, which of course is negative 5. So f of 3 is negative 5. Okay. So it's using function notation. I guess tons of experience with that. All right, so I kind of talked about some of the things you need to be thinking about when you're reading a word problem and trying to write an equation and stuff like that. So when given the situation, you want to identify what you're asking for. Okay, so make sure you're looking for that, and that's the information you're going to use to establish what variable you're going to use. So oftentimes we talk about defining a variable. It talks about that here, defined variable. So it's usually one of the first things you have to do is saying like, X is going to stand for the cost of apples, or T is going to stand for the amount of time passed, right? So you're picking a letter and then saying what it stands for. So it seems like a silly step, but it's actually really important. And then you're going to pick a different variable based on the changes that are happening that lead to that the question. Okay, so like if you're talking about time, like if T is standing for how much time has passed, then maybe C is how much it cost, per hour to have a babysitter or something like that. So you maybe have C as your other variable for a cost. They want to maybe sketch that situation or represent it, looking at different possibilities. So sometimes they make tables or, just write out values or things like that to, you're looking for a pattern, right? So how are things changing? And then that allows us to write the equation. So just trying to figure out what's changing, how are things changing, so that you can identify a pattern and then turn that into an equation. And then once you have that new equation or any other observations you made, you can use those things to solve the problem. So starting off with that idea that we want to define variables based on what the problem's asking for, what's changing in the problem. So we have a student that saved $3,500 for summer vacation. She anticipates that she'll spend an average of $400 per week, I guess, on the vacation, right? Write an equation to model the situation using defined variables, then use your model to answer the following questions. Okay, so they're asking us to write an equation about this. So we want to pick variables based on things that are changing in the problem. And so, looking at what it's talking about, right? It's talking about the amount of money that she has, and it looks like time, right? The amount of time that she's spending on vacation. So those are the two things that are changing in the problem, like how much time has passed and how much money she has. You get to pick the letters, but oftentimes it's helpful if you base it on what it's about. I wouldn't want to use like P to stand for time or something like that, because it just kind of comes out of nowhere. So, so one of the things I noticed again that it's in here is talking about that idea of number of weeks that are passing. Okay, so I'm going to use the letter W and define it as I guess that she's on vacation. Okay. And then, it doesn't really say it anywhere specifically, but the rest is talking about money, how much money she has. So then I'm going to use A, and I'm going to define that as the amount of money she has. So it wants us to write an equation for this problem. Okay. So based off of these variables, what should the equation be? And so one thing we got to think about is which of these variables is independent and which of these is dependent. And so that comes from that idea of, which one is changing because the other one is changing, right? So usually what I end up doing with that is like just looking at part of what the variable stands for. So is the number of weeks she's on vacation changing based on how much money she has, or is how much money she has changing based on the number of weeks? Okay, and sometimes it can be a little unclear. Like if you're having to pay to stay on vacation, right? Like you're renting a hotel or something like that, and then the amount of money you had could be a limiting factor, right? Like, if you think about it in that regards, I think what they're intending on this problem is that the amount of weeks that pass will change, and then the amount of money she has will change accordingly. That as the time goes by, she's spending her money. So this would be the independent, and usually time we would think of it as being independent. We can't change time, how time passes. So usually time is independent, and then the other variable, in this case money, would be dependent on it. How much money she has left would be dependent on it. So the dependent variable always acts like our y, and then the independent variable always acts like our x. So if we think about this in terms of what function notation looks like, that the f of x, right, the f of x here should act like our y. And so I'd want to say a of w, right? Notice where if I'm saying that this is the independent, which is what x is normally like, that should be inside the parentheses. So we'd say a of w. And what that means is the amount of money she has depending on how many weeks have passed. Okay? So since this is the dependent variable, it's changing because this one's changing. It acts like our y. It goes on the outside of the parentheses. This is the independent variable because it's not changing because of anything else. That acts like our x, and so it goes on the inside of the parentheses. So a of w equals, right? How are things changing? What patterns might we see, right? And so she's spending an average of $400 per week, right? And so when I see that word spend, that should indicate that her money is decreasing, right? So that's going to become a negative amount of money that she's going to have. And then the 400 per week, right? So every week that she's there, she's spending $400. And so per is a multiplication idea, right? If it costs me $3 per book and I spend, I buy 6 books, right? 3 times 6 would give you 18. So when you see that word per, it's actually a multiplication idea. So it lets me know that I should multiply the 400 and my variable. And again, notice where the variable is showing up here, right? 400 per week. So 400 times the number of weeks, and then the spending to tell us that it should be going down. And then last thing it tells us is, right, that she has $3,500 saved at the beginning. So she started off with $3,500, and it's decreasing from there. I'm just going to sketch a little bit what this graph might look like just as a way to start this, and it's going to talk about that later. I think it's just a good place to kind of start visually think about what the graph would look like. I'm only going to draw the first quadrant because we're not going to have negative time, right? The number of weeks can't be negative, so it wouldn't make sense to have any negative x values, right? If you think about that. And then I'm not going to have negative money, so I don't need space down here. So this would be my w-axis, because that's the x, and this would be my a-axis. So since it's acting like my y, and that's in money, and this is the number of weeks. Think about that. That would normally be our y-intercept. Well, our y is a, so it's going to be my a-intercept. So up here, wherever 3,500 is, that's my y-intercept. And then this has a negative slope, so it's going to be decreasing, right? The amount of money she has should be going down after for a certain amount of time. So it should look something like this. Let me draw a different color. Okay. So this would be our y-intercept or our a-intercept, and some of the problems in the textbook mention like t-intercepts or c-intercepts because they're replacing the y or the x with the letter that's kind of in their place, so it can be a little confusing. So let me just kind of highlight that. So here it says y-intercept. You could technically call that your a-intercept, since I'm using the letter a in the place of y. So what does the a-intercept represent in this situation? So we see that here on the graph. If you didn't have a graph already, how do you know what the a-intercept is? What we know about a-intercepts or or y-intercepts, sorry, is that their x value is 0. Right? It's a really important detail about those points, is that it's, if I had to write out the coordinates of it, that'd be 0, 3500. And so if you don't know the y-intercept, if it's not graphed for you or something like that, how do you find it? You make x equal to 0, or in this case, w equal to 0. So I'd be finding a of 0 equals negative 400 times 0 plus 3500. Well, of course, negative 400 times 0 is 0, plus 3500 would be 3500. So our a-intercept or our y-intercept is 3500. How do we represent that in context of the situation? Right, what does that mean? Really is what that's saying. Interpret it, tell us what that means. What did that $3,500 represent? Oops. Again, what I would have you guys do is think about that as a point. It's important to think about both values here and what they both mean. They both represent something. So our x, or in this case, w, right, 0 weeks. 0 weeks. It's my x value, which is my w. Okay? $3,500 is how much money she has. Right? That's my a value or my y value. So at 0 weeks, she has $3,500. We don't say 0 weeks. That's not how we talk. So as you're interpreting this, as you're translating this, right, you'd be a crappy translator if you're talking, going from Spanish to English, if the way that you speak isn't clear to whoever you're translating to. So you got to make sure that you translate in the way that we speak. We don't say 0 weeks. We say beginning or start or initially. Those are all things we say when we're talking about 0 time. Okay, you go back to the problem. She had saved $3,500. So she started with that amount of money, and it was decreasing from there. So you have some freedom in how you say that, but I don't want to see you should not be saying 0 weeks or anything like that. You should be saying at the beginning or at the start or initially she had $3,500. So interpreting that value, okay? So finding it and then interpreting it, okay? So to find a y-intercept, you plug 0 in for x, and then what does it mean? Again, here's the 0. All right, we're talking about both numbers. So if you don't use a phrase like this, it's not correct either. You need to talk about the 0, you need to talk about the 3,500, but we don't say 0, because we just don't talk like that, okay? What's the slope represent in this situation? Of course, the slope would be here, the negative 400. Remember, slope is rise over run, so it should be negative 400 over 1. So it is, again, important that you talk about both numbers here, not just the 400, but also the 1. So remember the rise, right, the change in the y values. Remember we're not using a, we're using, or y, we're using a. So that change in the y values or the change in the a values, what did a represent? Well, a represented the amount of money. So this would be a change in $400 per week, $400, right, negative $400. And then what did the x represent? Right, what were those x values? Well, we weren't using x, we were using w. We were using w because it was weeks. So it was 1 week. Okay. And then this word right here, right, this little slash is also a word. It's per. Okay. So what does this mean, right? Negative $400 per week. What does that mean in the context of this situation, right? That's where it's come back to this, right? That she's spending an average of $400 a week, okay? So that's how we represent that in the context of this situation. Again, they're giving us a lot of this information right now. We would then, later on, like with a more complex problem, we'd have to find the slope. This is kind of an easy starter problem, so just seeing how it's represented, like in the words, like how we talk about those things. So, again, $400 per week, but it's a negative, right? So how do you lose money? You spend it, right? So in context, again, it's not, she didn't say she has negative $400 per week. That's not how we talk, okay? We don't say negative money. We talk about spending money, losing money, things like that. So make sure your job is to translate. Your sentence needs to be in the way that we talk, not just, so I shouldn't be saying the word negative. It doesn't make sense. That's how that's not how we speak, so. But notice how the unit down here was 1, right? $400 every 1 week. That's how we talk. In the same kind of way, like things that we represent with slope in real life, like when you go to your job, you make $12 every 1 hour, right? You go, you're in your car and you're getting 30 miles to every 1 gallon of gas. You're out jogging and you're running 6 miles every 1 hour. Okay, so we like that change in the x values to be ones when we talk. It makes more sense to us. You go to the store and it costs $1.99 for every 1 pound of apples. Okay, so when we're talking about slopes in context of this real life, we like that denominator that to be in what's called a unit. Okay, so this denominator, the change in our x's, is represented as a unit, a 1. So that's the way we like to think, the way we like to talk. Oops. Why is it doing that? No, I don't want to. Sorry. How much money will she have after 4 weeks on vacation? So we say 4 weeks, right? So that means it's telling us that W equals 4. So essentially we're saying what's A of 4? Right, so that'd be negative 400 times 4 plus the 3,500. So that's negative 1,600 plus 300, which is 1,900. So she'd have $1,900. And then last question here, how long will it take for her to run out of money? So where is that indicated in the graph? That's kind of think about that here. So where does she have 0 money? Right here, right? And so normally we think of that point as being like our x-intercept, right? In this case, that would be our w-intercept, or our x-intercept, right? Well, what do we know about all x-intercepts, all w-intercepts, is that we don't know what the x value is necessarily, but we know that the y value is 0. Remember that y for us is, in this case, a of w is what's replacing our y. So we know that that whole thing is equal to 0. It's not saying that a of 0, where just w is equal to 0, right? Because w isn't equal to 0, the a is. Okay? So that's not right. We know that the whole thing is equal to 0. This is what y is. So it's getting replaced by 0. So we know 0 equals negative 400 w plus 3,500. We're going to solve for w. So I'm going to add that to the other side, so it'll be 400w equals 3,500, and then dividing by 400. That would come out to be, what's that, 8? Yeah, I think it's 8.75. So I know, it's 8.75 weeks, right? Because that's what W stands for, is weeks. I know one of the problems in the homework says, round down to the nearest week. So, if we rounded this, it would round up to 9 weeks. But, she technically doesn't have enough money to make it to 9 weeks because she, would run out of money partway through the week. So it said round down. So she only has enough money to make it through 8 full weeks. So when it says round down to the nearest week, that's what it's talking about, that we can't round up in a situation like this because we're out of money before we can get to that next full week. So just make sure you're thinking about that when it says that, why it says round down to the nearest week instead of just rounding like we normally would. So, okay. So a lot going on here, all these words, all these translations, a lot of thinking you've got to do, okay? Again, tricky problems. So I'm going to try one more, or sorry, two more. A company selling donuts, they incur fixed costs of $25,000 for rent, insurance, and other expenses. So the fixed costs are things that are just like set, and they cost $25 or 25 cents to produce each donut. Okay, so this would be called like a variable cost or a fluctuating cost because it changes about depending on how much of something you make. I want to write a linear model. Really, this is saying write a linear equation. Represent the value of C. So they're giving us a variable they want us to use. So that's the value of the company as a function of X. So they're telling us the other variable they want us to use. And X is the number of donuts produced. Okay. Then we're going to interpret the slope and the y-intercept in the context of this problem. So I'm just going to write these down really quick. Again, a couple things they're showing us. The value of the company based on the number of donuts produced. So notice here that we are not talking about the cost of a donut. That's not something we don't know. We know how much the donuts cost to make. We're not trying to figure out how much they should sell them for or anything like that. Okay, it's purely about the number of donuts. Okay, the count of them, the amount of them. Okay, and then C is how much the company is worth. And so probably a really important word in this when they say, identify the slope of the linear model represents. What you're looking for, we saw in the last one, it was the word per. We don't have a word per in here anywhere. What we do have, though, is this word each. Okay, so each and per are pretty interchangeable. Like you make $12 each hour, you 30 miles each gallon of gas. So that's really our word there that's telling us that that's the slope there. So if we think about how we would write that, so I do need to leave it as 0.25 because that's dollars, right? Per one donut. Okay. So of course M would just equal, in simplified terms would be 0.25. But what does it represent, right? And so I'm really saying that right here, right? How much they make, how much it costs them to make each donut. Okay. I'm going to switch it to say per this time, since I get to choose that. Costs, there we go. Our handwriting there. the y-intercept of this problem, again, that's kind of like a starting value. So what we're looking for there, usually when we talk about like fixed costs, that's a starting value, things that you have to pay ahead of time. If you like think about that, like pretty common problem is like a gym problem. Like it costs you $50 to join the gym, and then $10 every month to stay a member. You know, it's that $50 is the fixed cost, the fixed rate, fixed fee. That's like your y-intercept, your starting amount, right? And then the $10 is the repeating cost, the slope. You know, same thing. Like if you do a phone plan, like $100 to buy your phone, and then it's $25 a month to keep your phone going, right? And so the $100 would be that starting fee, that is your y-intercept, and then the repeated cost, the $25 a month, is the slope of that. So looking for things like that would be our y-intercept. Again, a y-intercept is a point, which means it has two coordinates, so 0 and then 25,000. Right, and remember what the 0 represents here is the other variable, right? The 25,000 is the cost, right? What was the other thing we're talking about? Well, this would be the number of donuts. And again, they used the letter X there. I might have used D, but then they called that C. So, oops, that's not meant to do. If at 0 donuts made, their costs are $25,000. Okay, so before they make any donuts, they've already spent $25,000 to rent their business space, to get insurance for their material, to buy materials to make the donuts and stuff like that. So when you start a business, you got a lot of money up front that you got to spend out. So, but again, that's starting, beginning, initial. Those are words that we use to talk about y-intercepts. Okay. So, you got some leeway in like how you kind of fluff up the sentence, but you need to have something about initial or start, beginning. It needs to be saying something about spending money, because where it was costs. And then, so I just added on their company, just kind of to round out the sentence. Well, it says spend, right? That makes sense. That should be a negative money amount, right? I was thinking there. And then they're spending money on donuts too. I'm sorry, guys. That should be costs, right? Those should be negative values there. So these are all things they're spinning out. So I want to write a linear model representing the value using that slope and y-intercept that we just had. So again, I'm going to use these letters here that we used earlier, right? So the C and the X. And so think about how we write that. That'd be C of X equals. Okay. And then my slope was negative 0.25, and then X, and then minus 25,000. Yeah, so that was silly of me to not think about that earlier, but costs, spending, those things all mean negative money. So when they're talking about the value of the company, right, the company has less value because they're spending money. So they weren't asking us to find out like how much total they had spent, what the cost of everything was. That would be an added. All right, last one. All right, city's population has been growing linearly. That just really tells us that the form of the equation, right? These are all linear equations, so it should have been slope-intercept form. So important, but not going to be anything different. In 2008, the population was 28,200. By 2012, the population was 36,800. assume the trend continues. Okay. Really what they're trying to do here is basically give us points. I guess the two things that are changing here, right? Population and then time. So I'm going to say, P is the population of the city. And then T would be the year. And then you pick the earliest one, years since, or number of years, sorry. Number of years since. You pick that first year. (2008). So I'm using that first value they gave me. What am I doing here? Wrong button. Okay, so since they taught, that's kind of the start of the problem. I'm using that number here. Okay. What I would notice with this, and the way I like to think about this, is like they're giving us 2 points. And so the population would be changing based off the years. So that would mean that this is my independent variable, and this would be my dependent variable. So the population is acting like my y, the time would be acting like my x. And so they're giving me points on a line, right? It's linear. And so since the time is my x, that means the 2008 would go there, and then the population of the 28,200 would go here. Sorry. So you do need to stop and think which one's independent, which one's dependent, which one's x, which one's y. And then the other point they're giving us, right, is the 2012, 36,800. Okay. So if we think about how things are changing, right, that's slope, that's, again, there's lots of different ways to think about it. You can kind of do it more casually. It's been 4 years, and the population increase looks like 8,600 to go from here to here. So every 4 years to go up 8,000, well, it's about 2,000 a year, right? More formally, slope is y, the change in y over the change in x. Okay, which is 8,600 divided by 4, which is 2,150. Okay, so every year it's going up 2,150. So in 2 more years, right, from 2012 to 2014. That's not supposed to say that. I should say 2014. In 2 more years, how much more to go up, right? So 2 times 2150 would be 4,300. Well, I would just add that to the population that I had, which was 36,800, which would be 41,100 people. Okay, so that is one way to do that. Again, another way you could do it would be to say P of t equals, and then my slope that we just found at 21.5, increasing this much per year times the number of years, and then plus that initial amount that you had, which was this. That was the initial amount, because that was our initial year. Okay, that was the beginning of the problem, 2008, so that was the population in 2008, plus the 28,200. Okay, and then I plug 4 into this. I make 4 year, not 4, sorry, I would plug 6, right? 6 years between this. So I plug 6 into here, and then multiply that by 6, and then add it to this. It would get us the same answer. So a couple of different ways to do that, but then it really comes down to finding slope, right? How are things changing? We needed that both times, no matter what. Okay. Here I was able to go off this year to this one. Okay. Because I was doing it more like a pattern based. Or here I had to use the initial values to make the equation, then I could plug the number in. Okay. So this is really better for a problem like B, because if I wanted to do problem B using this pattern, I'd have to keep sitting here adding 2150, add on to this. Okay, that's what it is in 2015. Add another one. Okay, that's what it is in 2016. Add another one. Okay, that's what it is in 2017. And then I have to keep doing that until I reach something like this. If I have the equation, then I can just say, well, the population is 54,000. And then I can just solve for t. So if I'm subtracting the 28,000 over, so what's that? 26, 25, 800 equals 2150 t, and then divide by 2150. And 25,800 divided by 2150 is 12. So be careful, because what did T stand for? Right? T stood for the number of years since 2008, and so 12 years after that would be 2020. So make sure you're reading the question, like what's it actually asking for. So it'd be 2020. Ooh, God, not 2020. So that would be when the population would hit 54,000. Again, not easy things to talk about. So just definitely would expect lots of questions here as you guys are doing this. That's just normal. These are tricky, so make sure reading the problems on the computer is going to be different now for you guys too. So just as you guys get started and start asking those questions, so as you're getting used to that, and then let me know.